For 60 years, we thought we knew how the universe began. A singularity, a big bang, space, time, matter, and energy expanding from an unimaginably hot, dense beginning 13.8 billion years ago. The story was clean, elegant, almost sacred. And for decades, the evidence seemed to point in one direction. But now, the universe is handing us clues that do not fit neatly inside that story. A ring of galaxies 1.3 billion light-years across. Early galaxies appearing where there should have been only cosmic seeds. Dark energy that may not be constant after all. The blueprint is tearing at the seams. And that forces the deepest question of all. If the beginning was not what we thought it was, what, if anything, came before it? The story we told ourselves for a century was elegant. In the 1920s, an astronomer pointed his telescope at mysterious clouds of light scattered across the night sky. For generations, many believed these clouds were part of our own galaxy. But what he discovered changed everything. Those clouds were not clouds at all. They were entire galaxies, island universes. And most distant galaxies were moving away from us. The universe was not static, it was expanding. Run that expansion backward, and the visible universe grows hotter, denser, smaller, earlier. Until every galaxy, every star, every atom, every photon, and every region of space we can observe today traces back toward an unimaginably compressed state. Not an explosion inside space, the expansion of space itself, the Big Bang. For hundreds of thousands of years, the young cosmos was a blinding fog, too hot and dense for atoms to hold together, too crowded for light to travel freely. Photons scattered endlessly through a plasma of charged particles trapped in the fire of the early universe. Then the fog lifted. Electrons joined with nuclei. Atoms formed. Light broke free. And that ancient light is still traveling through the cosmos today. We call it the cosmic microwave background, the oldest light we can see, the baby picture of the universe. It is not just a glow. It is a map, a fossil, a message written across the entire sky. From its faint temperature ripples, we extracted the universe's recipe. A small fraction ordinary matter, a much larger portion dark matter, and the majority in the form of dark energy, the mysterious force driving cosmic expansion. Think of the cosmic microwave background as a baby picture. The tiny temperature variations are not random noise. They are the seeds of everything, every galaxy, every cluster, every filament, every empty void between them. From those seeds, gravity built the cosmic web across billions of years. The timeline seemed clear. Dark ages, the first stars, cosmic dawn, galaxies slowly assembling, clusters growing, the universe maturing step by step. The model looked almost airtight, but a theory is only as strong as what it can survive. And when we finally built instruments powerful enough to stare into the universe's infancy, the cosmos refused to behave. The James Webb Space Telescope was built to look deeper into the past than any telescope before it. Because light from the early universe has been stretched by cosmic expansion, ancient starlight reaches us in infrared. Webb was designed to see that stretched light, to look back toward the first galaxies, to watch the universe grow up. But what it found was disturbing. Galaxies appearing only a few 100 million years after the Big Bang. Some brighter than expected, some more massive than expected, some showing signs of chemical maturity earlier than our simplest models predicted. Not one clean anomaly, not one harmless outlier. A growing population of early galaxies forcing astronomers to ask whether the first structures formed faster, brighter, and more efficiently than we thought. Imagine planting an acorn and returning days later to find a young tree already reaching above your roof. That is the feeling Webb has given cosmology. Where we expected primitive seeds, we are finding galaxies already burning with surprising intensity. Where we expected a slow, fragile beginning, we are seeing signs of acceleration. Stars formed, elements appeared, galaxies assembled. And it all seems to have happened faster than our old picture allowed. The standard model is not dead, but it is under pressure. The early galaxies are only the first crack. The second is harder to ignore. Cosmology rests on a simple principle. On the largest scales, the universe should look roughly the same in every direction. No special center, no privileged location, no gigantic pattern that makes one side of the sky fundamentally different from another. This is the cosmological principle. It is one of the pillars holding modern cosmology together, and for a long time, it seemed to work. At smaller scales, the universe is messy. Galaxies cluster, voids open, filaments twist across space. But zoom out far enough, and the mess should smooth out. Like stepping away from a painting until the brushstrokes vanish. Above roughly 1 billion light-years, the universe is expected to become statistically uniform. Then came the structures that should not be so easy to explain. The giant arc, a sweeping structure billions of light-years across. And nearby, the Big Ring, a vast arrangement of galaxies and galaxy clusters spanning about 1.3 billion light-years in diameter, with a circumference of roughly 4 billion light-years. A ring so enormous that it sits exactly where our models start to sweat. For perspective, our own cosmic neighborhood, the Laniakea supercluster, spans hundreds of millions of light-years. It is already almost impossible for the human mind to imagine. But the Big Ring is larger. The giant arc is larger still. These are not small ripples. They are colossal patterns in the distribution of matter. If confirmed as real coherent structures and not statistical alignments, they may be cracks in the cosmological principle itself. If the universe is an ocean, our models predicted that on the largest scales the waves should smooth out. Instead, we are finding shapes that look far too large to be ignored. A ring, an arc, structures so vast that they force a dangerous question. Is the universe truly smooth at the largest scales? Or have we only been looking at a small part of something far more uneven? And then there is dark energy, the invisible pressure behind the universe's accelerating expansion. For decades, the simplest model treated dark energy as constant, a fixed property of space itself, a cosmic engine that never weakens. If that is true, the universe expands forever. Galaxies drift beyond each other's horizons, stars burn out, black holes evaporate, the cosmos fades into a cold, dark eternity. But new measurements from massive galaxy surveys are beginning to hint at something more unsettling. Dark energy may not be constant. It may evolve. It may change over cosmic time. It may have been stronger before, or weaker, or something stranger than a simple constant written into empty space. If dark energy evolves, then the fate of the universe is no longer locked into the simplest version of eternal acceleration. The future opens again. Expansion could continue. It could slow. It could change character. The universe may not be following the script we gave it. And that brings us back to the forbidden question. If our model is incomplete, what actually happened at the beginning? And what, if anything, came before it? One answer begins with inflation. In the standard Big Bang picture, the early universe has a problem. It is too smooth. Regions of space so far apart that they should never have exchanged information have almost the same temperature. How did the universe coordinate itself across impossible distances? Inflation offers an answer. In the first tiny fraction of a second, space may have expanded exponentially. A burst of growth so violent that it stretched microscopic quantum fluctuations across cosmic scales. It smoothed the universe, flattened it, seeded the structures that later became galaxies. Inflation is elegant, powerful, widely studied, but it leaves a shadow behind. What started inflation? What ended it? And what existed before that first explosive stretch of space? The answer may be nothing, or the question may be wrong. Because some theories suggest the Big Bang was not the beginning at all. Maybe it was a transition, a rebound, a doorway. In some cyclic models, the universe does not begin once. It breathes. Expansion, cooling, darkness, contraction, collapse. And then somehow, a new beginning, a new Big Bang, a new cosmic cycle. Our universe would not be the first. It would be one pulse in an ancient rhythm, one breath in a sequence with no true beginning, the end of one cosmos becoming the birth of the next. And then there are stranger ideas still. Perhaps our universe is not everything. Perhaps it is a membrane, a vast three-dimensional surface floating in a higher dimensional reality we cannot perceive. In this picture, other universes may exist nearby, separated from us not by distance in ordinary space, but by dimensions our senses cannot access. If two cosmic membranes collide, the impact could trigger a big bang. Not from nothing, not from a single beginning, but from a collision in a deeper reality. Imagine two sheets hanging in darkness, slowly drifting until they touch. Where they collide, a universe is born. Maybe ours began that way. Maybe others did too. These ideas sound almost impossible to test. For now, many of them are. But the history of cosmology is the history of impossible ideas becoming measurable. The expanding universe once sounded absurd. The cosmic microwave background was once only a prediction. Dark matter was once an invisible patch on a broken calculation. Dark energy was once a shocking surprise hidden in exploding stars. Each generation thinks it has reached the final story. Then the universe opens another door. We began with a question. What existed before the universe? But we end with a deeper one. Do we even understand the universe we have? The data pouring in from our telescopes is not just adding details to the standard model, it is testing its foundations. Early galaxies are forming faster than expected. Structures are appearing on scales that strain our assumptions. Dark energy may not behave like a simple constant. And somewhere in those cracks, the next revolution may already be waiting. Maybe the Big Bang was the beginning. Maybe it was not. Maybe our universe emerged from inflation. Maybe it rebounded from a previous collapse. Maybe it was born from a collision in a higher dimensional space. Or maybe the truth is stranger than every model we have dared to imagine. The most terrifying possibility is not that we were wrong about everything. It is that we were only seeing the first layer. A clean story, a beautiful equation, a universe that looked understandable because we had not yet built instruments powerful enough to reveal its scars. Now, we are seeing them. The ring, the arc, the ancient galaxies, the shifting darkness behind expansion. The seams are showing, and if those seams tear open, they may reveal that the Big Bang was not the first page of reality, only the first page we were able to read. Maybe our Big Bang was not the first. Maybe it was not even the beginning. Maybe the universe has been dying and reborn for eternity, and we are living inside one breath of something far older than time. Subscribe to Cosmos for deep space documentaries every week. The mystery is only getting bigger.